Hello, dear students. In this video, we will be talking with linear inequalities in one variable, which was taken from the module titled Linear Equations in One Variable by Maria Lenore B. Barcenas. At the end of this video, you are expected to illustrate linear inequality in one variable, find the solution of linear inequality in one variable, solve linear inequality by first graphing and second by algebraic method, and last, solve problems involving inequalities in one variable. Last time, we had discussed on how a number followed by a variable added with another number, which is now called an algebraic expression, evolved into an equation by having the equal sign followed by another expression. This form is called linear equation in one variable. This time, since we are discussing on linear inequalities in one variable, from this expression, we now have to change the equal sign using any inequality symbol, and that gives us now a linear inequality in one variable. By definition, a linear inequality in one variable is a first degree polynomial inequality, meaning the highest exponent of the given variable should be 1 and can be written in the standard form ax plus b is greater than 0, where a and b are real numbers and a should not be equal to 0. So in this form, ax plus b is greater than 0, the two capital letters here represent real numbers. And we also have here a condition wherein a should not be equal to 0, or the numerical coefficient of x should not be equal to 0, because in that case, if a equals 0, then we have 0x. It now omits our variable, which is x. And that should not be, because this must be an inequality in one variable. Examples. We have x minus 14 is less than 0. Take note, there are four inequality symbols. We have greater than, less than, greater than or equal to, and less than or equal to. So you can use any of those four inequality symbols in writing a linear inequality in one variable. Second, we also have 3y is greater than 45. And last, we have 3 times n plus 5 is less than or equal to 2n plus 6. So as you can see, we only have one variable in each example with a degree or exponent of 1. And they all have inequality symbols. So that is what a linear inequality in one variable is. Let's now have the different properties of linear inequalities. First, we have the addition property of inequality, or the API. It states that if an inequality exists, Adding or subtracting the same number to both sides of the inequality does not change the inequality. So say for example, we have the inequality 6 is greater than 4. For the addition property of equality, you will not change that given example if you add or subtract something to both sides of the inequality. Let us see. So if we have 6 plus 2, then it is greater than 4 plus 2. It is correct because 8 is greater than 6. So if we subtract 5 to 6, we should also subtract 5 to 4. So that 6 minus 5 is greater than 4 minus 5. Or 1 is greater than negative 1. Next, we have the second property, which is the multiplication property of inequality, or the MPI, which states that if an inequality exists, multiplying or dividing the same number to both sides of the inequality does not change the inequality except negative numbers. So the inequality will change if we multiply or divide negative numbers. Example. Again, we have the inequality 6 is greater than 4. So if we multiply both sides by 2, it now becomes 12 is greater than 8. Note that inequality is still true. Same is true when we divide both sides by 2. So we have 3 is greater than 2. Still, that inequality is true. Let us have negative numbers. So if, say for example, we multiply 6 by negative 1, that is now negative 6. And then 4 by negative 1, so we have negative 4. So that is now negative 6 is greater than negative 4. Take note that inequality now is a false statement. Same is true when we divide both sides of the inequality by negative 2. So we have negative 3 is greater than negative 2, which is again a false statement. So what will we do when we multiply or divide a given inequality by a negative number? To make that inequality a true statement, even if we divide negative numbers, we have to reverse the inequality symbol. So if from here we have, say for example, multiplying negative 1 to both sides of the inequality, we have negative 6 is greater than negative 4. To make it a true statement, we must take the reverse of the greater than symbol, and that is less than. So we now have negative 6 is less than negative 4. Take note, it is already a true statement. Remember, the opposite of greater than is less than, and the reverse of greater than or equal to is less than or equal to. Let us now proceed to the graph of linear inequalities. We use an open circle or a not shaded circle if A is not included in the solution set. If A or the given number is not included in the solution set. This is used in less than or greater than symbol. So if, say for example, x is less than a, then we are considering all numbers on the left side of A in a number line. And for greater than A, we are considering all numbers to the right of the given number. And a closed circle or a shaded circle means A or the given number is included in the solution set. It is included if the inequality symbol used is less than or equal to or greater than or equal to. So if we have x is less than or equal to a, then we have the solutions a and all numbers to the left of it. But if we have x is greater than or equal to a, then we are considering all numbers, including that number a and all numbers to the right of it. So that's the graph of a linear inequality in one variable. Let us now solve linear inequalities using the two properties that we have discussed. First is using the addition property of inequality. Solve x minus 3 is less than 6 and graph the solution set. So we have x minus 3 is less than 6. That's the given inequality. Now to solve for the solution set of x, we have to get rid of this minus 3. And that is simply done by adding 3 to both sides of the inequality, like solving linear equations in one variable. So, negative 3 plus 3 now is 0. So, we now have x is less than the sum of 6 and 3, which is 9. Therefore, x is less than 9. For the solution set, we have x is equal to x such that x less than 9. Graphing the solution set, we have here from 9, take note, we must use an open circle because we use the inequality symbol less than. So, the solution set are all numbers to the left of 9. Next, we have another example. Solve 13 is greater than or equal to y plus 8 and graph the solution set. So we have the inequality given. 13 is greater than or equal to y plus 8. Now to solve for the value of y, we have to get rid of plus 8 and that is done by subtracting 8 to both sides of the inequality. So we now have 13 minus 8, that's 5, is greater than or equal to y. This 8 and negative 8 will be cancelled. Therefore, the solution set of y is y such that y is less than or equal to 5. So the graph of the solution set, we have a closed circle on 5 and all numbers to the left of it. So y can be 2, it can be 0, or it can be a negative number. Next, we have solving inequalities using multiplication property of inequality. First example, solve w over 2 is greater than negative 1 and graph the solution set. So taking the given inequality, we have w over 2 is greater than negative 1. So to remove that over 2, we have to multiply both sides by the divisor, which is 2. So we have on the left side of the inequality, cancel 2, we have w. Or 2 divided by 2 is 1 times w is w. Is greater than negative 1 times 2 is negative 2. So we have the solution set W such that W is greater than negative 2. So for the graph of our solution set, we have all numbers to the right of negative 2, excluding negative 2. So we have an open circle at negative. Another example, solve negative 2070 is greater than 9 and graph the solution set. So again, we have the inequality negative 2070 is greater than 9. Take note, a number followed by a variable implies a multiplication operation between them. Therefore, to remove negative 27, we use the opposite of multiplication, which is division. So dividing both sides by the numerical coefficient of t, we have negative 27 divided by negative 27. That's 1 times t. We have t. And 9 over negative 27, that cannot be divided, but we can reduce it in its lowest term. So we have negative 1/3. Therefore, the solution set is t such that t is less than negative 1/3. For the graph of the solution set, we have an open circle at negative 1/3, and the arrow is to the left of that given number since the given inequality is less than. So we have all numbers to the left of negative 1/3. Next, we have solving inequalities using both two properties, API and MPI. Take note, in using both properties, we have to start with the API. Example, solve 5 minus 3L is greater than or equal to 17 and graph the solution set. So we have 5 minus 3L is greater than or equal to 17. So we have to get rid first of 5, or the term without the variable. So to do that, we have to subtract 5 to both sides of the inequality. So we have negative 3L is greater than or equal to 17 minus 5, which is 12. Now, to solve for L, we have to get rid of negative 3, and that is done by dividing both sides by negative 3. So we have L is less than or equal to negative 4. So our solution set is L such that L is less than or equal to negative 4. Take note, for this example, we have divided a negative number to both sides of the inequality. That's why there's a need for us to change the inequality symbol from greater than or equal to less than or equal to. Don't forget that rule. So for the graph of the solution set, we must consider the number negative 4 and all numbers to the left of it. Take note in this example. Take note in this example, we have reversed the inequality symbol. So from greater than, we now have less than, since we divided a negative number to both sides of the given inequality. Next example, find the value of negative 2 times 4s plus 3 is less than negative 14. In this example, we have a parentheses on the left side of the inequality. So before we use the API and MPI, we have to simplify that first by distributive property. So we have negative 2 times 4s, that's negative 8s. Negative 2 times 3, that's negative 6. Take note, from that, you cannot change yet the given inequality because we just multiplied a negative number on the left side of the inequality. It is only applicable to reverse the inequality symbol if we are multiplying or dividing both sides of the inequality by a negative number. Simplifying further, we have negative 8s minus 6 plus 6. That is to remove negative 6 is less than negative 14 plus 6. So we now have negative 8s is less than negative 14 plus 6 is negative 8. Now, since we have a numerical coefficient for s, we have to divide both sides by negative 8. Again, dividing a negative number to both sides of the inequality, we have to reverse the inequality symbol. So from less than, we now have greater than. So s is greater than 1. For our solution set, we have s such that s is greater than 1. For the graph of the solution set, we have this one, an open circle at 1 since we used greater than symbol. That means the solution set consists of all numbers to the right of 1. Next, we have solving real-life problems involving linear inequalities. This example, it costs Darius 500 pesos to make brownies for the school fair. How many brownies must he sell at 12 pesos each to make a profit? So for the solution, we have to let values for the given problem. We have B, that's the number of brownies that must be sold. And 12B, be the amount earned. Because we have 12 pesos for each brownie that Darius can sell. Because we have 12 pesos for each brownie sold by Darius. So we have 12b is greater than 100 because to make a profit, we must earn more than 500 pesos. So after selling the brownies at 12 pesos each, we must have greater than or more than 500 pesos. So to solve for that, we have to divide both sides by 12. So that's B is greater than 41.67. But since we cannot sell a fraction of a brownie, then we have to consider 41 brownies. So to earn a profit, Darius must sell more than 41 brownies. Another example, Caitlin is celebrating her birthday. Her parents gave her 2,000 pesos to take her friends to the movies. If each ticket costs 220 pesos and she needs to buy tickets for herself and her brother, what is the maximum number of friends she can invite? So first, we have to let T be the number of movie tickets. That means the total amount of tickets for friends is 220 T. So for the inequality, we have 440 plus 220t is less than or equal to 2,000. So it must not exceed the amount given by her parents. We have to add 440 because this is for the tickets for Caitlin and her brother. This 220T is only for the tickets for the friends of Caitlin. Working on the inequality, we have to subtract both sides of the inequality by 440. So that is now 220T is less than 1,560. And dividing both sides by 220, we have T is less than or equal to 7.1. But since we cannot buy a fraction of a ticket, so that means Caitlin can only invite at most 7 friends. So that ends our discussion for linear inequalities in one variable. But before we end this video, always remember when we say linear inequalities in one variable, it's a 1 degree inequality in the form ax plus b is greater than 0, where a and b are both real numbers and a should not be equal to 0 because we must have one variable on the inequality. And you can use any of the four inequality symbols. We have greater than, less than, greater than or equal to, and less than or equal to. To graph a linear inequality in one variable, we must use an open circle if the inequality symbol used is either greater than or less than, and a closed circle or a shaded circle if the inequality symbol used is greater than or equal to and less than or equal to. In solving linear inequalities in one variable, we must apply the addition property of inequality, the multiplication property of inequality, or both the two given properties of inequality. And don't forget to reverse the inequality symbol if we are multiplying or dividing both sides of the inequality by a negative number. And in solving problems, you simply have to apply what you have learned in solving linear inequalities in one variable. Always remember that most problems in real life do not use of the fraction of the given number. So you must consider the integer part or integer values. That's all. Thank you for watching.